Hello. So let's start with a new trick. Find size of an array using pointer. So basically how usually we find size of an array. So in C we basically take integer of, let's suppose it represents size of an array is equal to size of array divided by size of array array's first element, or basically we can say integer. So this is how we find size of an array using a function. Using a function. Okay. So now we have to find size of an array using our pointers. Using pointers. So how it will work? Let's first check whether it is printing size of an array or not. Here n is using pointer, size using function, and size using pointer. Size using pointer approach. So let's print size of ptr. So let's compile. Yeah, it is compiled. So let's run it. First of all, let's comment it so you didn't confuse. Again compiling, running. So it will give array of size 5, array of size of 5 by using pointer. Let me using pointer and using function, size of function. Let's here function. Let's print both the size. Yeah, using pointer it also giving 5. Using function it's also give 5. Using pointer it also give 5. So how the pointers work? First of all, let's understand how these two statements work. It's an array and ampersand array. We are using address of array. So let's try to print this two statement. Let's clear. Again compile, run, see. Now you can see both the pointers are pointing towards starting of the array. This is basically start of an array. So if we see a array, it will give starting. It represent starting of an array. Of an array. Okay. It's basically giving same value. So now how will it how we can find using these two variables? How we can find the size of array using these two variables? So let's run again to more condition. If we are incrementing array and other is we are incrementing address of array. So what we can see here? Let me compile it. Yeah. So after increasing value by 1, as we can see, if we are increasing value by 1, this is the pointer we are giving from array, matlab this is our array and this is our ampersand array. So what we can see, these two values are not same after increasing. Let me clear it little bit. Yeah. So let's compile again. As you can see our previous, if we are not incrementing, the both the pointers are pointing towards to the same. If we are increasing the pointer by 1, as we can see both the pointers give different value. Why why this is so? So basically we now we can see the theory part. So basically it is like that. If we are basically our two pointer, which is our ARR and, let me rub this, ARR and ampersand ARR. What is this and what is this? How this will work? So basically ARR, it's any hexadecimal number. It is also represent a hexadecimal number. So what are these two used for? Basically this array, we have we are having array. Suppose this is our 5 and 1 2 3 4 5, and this is our index 0 1 2 3 4. So what this will do, this is basically a pointer which pointing towards array's first index. uh, Keep the address of the first index. Basically keep the address of a index of this variable, this this index, while at ampersand ARR, what this will done, let me do it. This will holds the address of whole array, whole array. This will hold the address of whole array. Remember this. This will hold the address of whole array if we are using ampersand before the pointer. So it will indicate whole array. So how it will work? If we increase ARR by 1, so it will now pointing towards the second index. Matlab means we are pointing towards 1. Previously we are having our index 0. After incrementing we are having our index 1. So if we are doing ARR plus 1, then our pointer data will be 2. Okay, and if we are incrementing array, ampersand array, by 1, what will it gonna do? It will basically, ampersand array holds the address of a whole array. So if we are increasing array, so increasing by 1, so basically we pointing towards the end of the array. So basically if we are having 5, we are having 4 elements, 0 to 4 elements in an array. So after that, pointing the next address of the array. Simple. Basically it's point the next address of the array, not not inside the element, outside the element, the next contiguous address of the element, address of the array. So it will something like something like a hexadecimal value, same as, but different from this one, this current index 2, which is holding which is basically array 1, which is different from this element. And how can we use these two variable for for our finding of size of array? So basically if we are performing ampersand ARR plus 1, it will give some hexadecimal value, let's say 0x 61ff0c. It is random variable, random value, so don't be stuck with it. It is a random variable. So if we are according to the pointer arithmetic, according to according to pointer arithmetic, how it is calculated? It is calculated from the base address, which is basically ampersand ARR plus 8. So this is how it is calculated, base address and plus 8. What is base address over here? Suppose base address will be uh, ampersand ARR having a value of 0x61 FEEC. So this is how calculated 0x61 FEECE plus 8 according to pointers arithmetic. Arithmetic. Simple. So how can we use this? Now, if we compute our value, as you can see in the function here, we are using ampersand ARR plus 1 increasing by 1 and decreasing our array. So how can we do this? So basically ampersand ARR plus 1 minus ARR. So this will looks like something, the base address of the array 0x61 FEEC plus, suppose above we have a size of 5, so it will be increasing by 5 plus 5. So our this minus base address, because base address of these variables are same, so it will be same 0xFEEC. So what will it gonna return? It gonna return 5. So this is how we are finding size of array using pointer. Okay, so let's see then, why do we use uh, star before ARR? Why do we use star before ARR? In this case, why do we use this star? Uh, for this, why do we use star? Because ampersand ARR holds the address. Basically, it holds the address of whole array. Whole array. Basically, it's ampersand ARR holds the address of AR array. So we using star to convert it into integer pointer. Basically, we have to convert it to the integer pointer, and integer pointer. Then we have to subtract the address of the first element. Subtract the address of the first element. So we will finally gonna return 5. We can finally, at the end we will get 5. So thank you.